This Fleet Equipment Unscripted interview is presented by Hendrickson, a leading manufacturer of heavy-duty suspension systems and components to the global commercial transportation industry. Visit hendrickson-intl.com to learn more.
Hi everyone, I'm Jason Morgan, Content Director for Fleet Equipment, and welcome to Fleet Equipment Unscripted. Again, another great surprise. Dwayne Teagles, Powertrain Product Marketing Manager, Volvo Trucks North America, back in the studio. Great to have you back.
Thank you for another invite, Jason. It's a pleasure being here.
Yeah, I mean, we're going to get used to this. You know, you keep showing up, you're going to be a co-host here pretty soon. So
Looking forward to it.
So glad to have you. Really want to, I know we touched on fuel efficiency and kind of the holistic picture last time we talked. I want to dive into that and really understand the technology, the hard parts components that are going into this. Volvo recently, not too long ago here, announced that turbo compounding is going to be standard on V&L sleepers on highway models. I want you to take me through turbo compounding. What is it? How does it work? And what are the benefits here?
Great question. When we look at turbo compounding versus our previous VGT, or current VGT, I should say,
right.
When we look at the engine, the internal components of that engine are the same. It's got the same crank, rods, pistons, valves, everything that's been tried and true with Volvo for many years. Mm-hmm. The difference is how the turbo functions. We put the turbo compounding unit on our proven D13 engine to look at it and add additional efficiencies. Sure. That's really what it boils down to. How that functions, we can go into the details if you like.
Yeah.
I think we got some images here.
Oh, yeah.
Share.
Okay. Yeah, let's check it out.
Okay, so what happens there is that obviously it's hanging on the right side of the engine, and exhaust is going to come from the exhaust manifold. Okay. You can see there by those two red arrows. Okay. Then what it does is it goes across that turbine just like a standard turbo. Right. Just like the first turbo we put on our trucks in the 50s.
Right.
So no difference. This is a fixed geometry turbo, so it's a very reliable, tried and true, proven design. Fixed design.
Okay, yeah, I want to stop you real quick there because you mentioned the VGT earlier, the variable geometry turbo. And my turbo recall's a little rusty here. Sure. What's the difference and why is this a fixed?
Well, we're able to gain additional efficiencies through the turbo by making it a fixed geometry. Typically a variable geometry increased RPM as we increase load.
Right.
With this new design, we've just been able to gain additional efficiencies, and it's simply less complex than what a VGT would be.
Sure.
VGT has a lot more moving components to it, where this is pretty simple.
Okay. Good. So take me through the rest of this.
Okay. So again, power goes through that turbine, again, spins the shaft and turns the compressor wheel and sucks in air from the air filter, just like any other normal turbo, and then would throw it over to the intake side of the engine to help out with fuel mixture, giving even greater efficiency. Okay. And at that point in time, if you were looking at a VGT, the exhaust would naturally go to the exhaust after treatment system. So it just kind of stopped. But our Volvo engineers looked at us like, well, we've got some more heat, we've got some more energy here. Sure. What could we do with it?
Right.
So we put another turbine behind the turbo. It's like, it's kind of like a windmill behind a windmill.
Okay.
So we spin that turbine up, and then the exhaust would go to the exhaust after treatment system. And then you can follow that shaft over there, and it goes to a hydraulic coupler.
Okay.
And that hydraulic coupler, it's filled full of oil. And if you look at it, it kind of looks like it's got kind of two paddle wheels.
Yeah.
Well, that paddle wheel on the right side there, it kind of grabs that oil and throws it up over to the left-hand side. Very similar to a torque converter you have in your car today.
Okay.
Very reliable component, pretty simple design. It's just two paddle wheels and two bearings. There is no additional service that goes along with it. We don't have to drain the oil in the hydraulic coupler. It fills up and drains out just like when we run it.
Okay.
So, and then the power goes down through the set of gears there we have, and we get 50 horsepower driven right to the crankshaft. Now, the interesting thing about that is Volvo has one of the most robust bottom ends out there. So if you look at like a 455 horse engine, that revolving assembly on our VGT is making 455 horse with those pistons. Well, with the turbo compounding engine, that engine now only has to make 405. So we go ahead and reduce the stress on that revolving assembly and capture that power from the exhaust stream.
I see.
So it unloads that robust bottom end.
Right.
And it also has less vibrations because we're able to run that engine at lower RPMs. So we run it at, below 1,300 RPMs is peak power with that. So it's quieter, it has less vibrations. It's just a complete different experience for the driver.
Okay, a couple of quick things even for my clarification. So the turbo compound, are these different components? These are separate components, right? So the turbo's the turbo, the turbo compounding component, they're different components, right?
They are separate components.
Okay.
I mean, they come together as one,
Okay.
but the turbo itself and the turbo compounder are separate components. And Volvo thought so much of this product that we kind of put it into our engine warranty instead of having a separate turbo warranty.
Okay, perfect. Oh, and that was going to be my next question in terms of reliability, versatility, fleets, especially when you start talking about engines and changing the way they operate. They want to make sure that they're going to be reliable, right? The reliability is there. Is there any education there that has to go on in terms of making fleets comfortable with the technology or understanding the reliability of it?
From a reliability standpoint, the D13 turbo compounding engine is just as reliable as our VGT.
Okay.
Again, it's the tried and true engine that we've had. The difference is just the turbo compounding hanging on the right-hand side. And with that, we've been able, again, as I mentioned, we've been able to reduce the RPMs that the TC engine runs at. So it saves wear and tear on our engine as well.
Right. Well, and it's not... you keep iterating on it and making it better, but it's not. This has been around for a while. You've been doing turbo compounding here for a while now, I feel like, too.
Yeah, we have. Turbo compounding was first introduced in 2017.
Oh, yeah. Okay.
And we have approximately 20,000 of these engines on the road today. And we have approximately, I think we just went over 1.5 billion miles with those engines.
That's a few miles.
It's tried and true. It's doing very well.
Awesome. The other thing, last time we were here, we talked about efficiency. One of the big takeaways, too, was if we're talking about truck efficiency, we just can't talk about the engine. Like, this is a great efficiency gain here, too, but it's part of a system. You got the transmission, you got the axle, you have the intelligence layer that goes over it to manage that. You've mentioned some of the horsepower and RPMs that we're running at.
Yep.
Can you take me through how are you managing the powertrain now to pull out even more efficiency from the vehicle?
Yeah, I think that gets into our I-torque conversation.
Okay, right.
And kind of some faster rear axle ratios that maybe the industry may not be accustomed to.
Okay.
We've done a different spin on this. Our I-torque setup is in our V&L product only. Mm-hmm. Okay, it's available in a 405, a 425, and a 455 engine. Mm-hmm. Now we've coupled our 13-speed transmission in that because we're putting in 215, 216, and 217 rear axle ratios.
Right.
So startability kind of comes into play there. It's, wow, what are we going to do? Is that thing going to be able to pull a load up a hill?
Right.
So we put a 13-speed transmission in there, and the first gear is 17.5 to 1.
Okay.
So that gives us some great startability,
Right.
about 20% startability. And it allows us to use the top 3 gears at road speed,
Okay.
which is kind of unheard of. This industry standard, when you're running a manual transmission,
Right.
the rule of thumb is keep it in top gear as long as you can.
Yeah.
Well, this system's designed to run in the top 3 gears,
Okay.
depending on the terrain and the speed, which gives you a great amount of versatility.
Okay.
And I guess why is versatility so important? A lot of our customers, when they spec a truck, they set it up for a certain duty cycle.
Right.
And the life expectancy of a truck is 5 to 7 years, depending on the customer, typically.
Right.
Some run them longer, some run them shorter, but that's where we typically see those trade-ins.
Right.
And in that time period, I guess we see economic situations change. Whether freight rates go up or fuel prices go down.
Right.
When we lock in a truck spec, we lock it in for the whole time of that truck. Okay, so now all of a sudden, and we've seen this over COVID, that freight rates went through the roof, right, as COVID was coming over. So what happens is now people naturally want to go faster to bring in more gross revenue. Well, that truck that was spec'd for 65 miles an hour, now it's inefficient.
Right.
or then fuel prices drop,
Right.
or fuel prices spike, I should say.
Right.
And now we want to go slower.
Right. Well, and even, I mean, we saw a lot of fleets getting in the different applications and different duty cycles with the same vehicles at that time too, just to make deliveries gain some more business. And you were seeing trucks going in the applications that they were not specifically spec for. To your point, you're kind of stuck there. I know even we've had conversations, even when the cameras aren't rolling, on perceptions that I need a certain amount of torque or RPM or power to get the job done right. How do you manage those expectations and still ensure that you can get the efficiency and the power you need when you need it? Yeah,
and we do that through software.
Okay.
We do that with a mixture of software. We do it with the transmission, and we, again, as I mentioned, we use the top 3 gears.
Okay.
So we use a system called IC, which is a proprietary map-based topography software.
Sure.
So what it's going to do is that vehicle coming into a hill, okay, it's going to go ahead and do a downshift before it gets into the hill.
Okay.
It knows the hill's coming up, and it's going to do that downshift to increase engine horsepower to keep that momentum coming into a hill.
Sure.
Instead of getting in the middle of the hill and then doing a downshift.
Right, right.
Okay. And then it's already done the calculation to the top of the hill. It knows, hey, how fast how high it is and how fast it's going to crest the hill. So it may go ahead and disengage the engine with the rest of the driveline. And we'll coast over the hill and down. And if we start overspeeding, the exhaust brake will kick in. So it's riding that momentum wave, almost like riding a surfboard. You know?
Right.
So that's how we start to gain that efficiency.
Very cool. Okay, great. I think you brought some more graphics here. I love this. We got more clips. We're going to another clip, right?
Right.
All right, show me here. Walk me through this.
Okay, so what you see here is the Volvo torque curve.
Okay.
And you want to take a look at this next up spot here. We've got 1,850 pound-feet of torque coming in there at 900 RPMs.
Oh, wow. Okay, yeah.
So that's... the clutch engage is typically about 850.
Okay.
So as soon as that clutch engages, we've got full torque.
Oh, wow.
So that truck is a torque monster. it's going to charge. And then that continues to pull all the way up to 1,300 RPMs. And you can see that we've got 1,840 pound-feet all the way out to 1,300 RPMs.
Okay.
So that truck's going to continue to pull. And unlike some other engines, this is going to peak out around those RPMs. So it's a weird experience for some of our drivers. Like, well, it's not running as high on the RPMs.
Right.
Well, it's not designed to.
Right. Okay.
And then when we look at the efficiency here, we got an efficiency. We try to keep it in that 900 to 1,300 RPMs. The lower we can go ahead and run an engine as far as RPMs, the more efficient it's going to be. And that gets into a conversation of what we call pumping loss. Mm-hmm. It takes energy just to rotate the crank, move the pistons up and down, turn the crankshaft, fire the injectors. It takes energy to do that. So if we're able to run an engine, say at 1,300 RPMs versus running at 1,700 RPMs, there's about 30 horsepower that's just used to rotate that internal component. So if we're able to go ahead and run that engine at lower RPMs, we're able to use that power and efficiency to turn the wheels instead of just turn pistons.
Right.
It's a term called pumping loss.
Okay.
Then if we look at what's going on, let's compare it to a 308.
Okay.
It's a pretty common spec that's been around for a while. Some of our customers still request that. But a 308 running 68 miles an hour, as you can see by the graph there, it runs at 1,400 RPMs. Now, it's able to go ahead and have a 1.5% grade. Now, what does that mean? That means over 1,000 feet, it'll go up 15 feet in elevation before it has to do a downshift. Mm-hmm. So it'll stay in top gear on a 1.5% grade with 455 horse, carrying 80,000 pounds. All kinds of technical information. So that's top gear with a 308. So now let's take a look at it as compared to a 215, a rear axle ratio. That's not a common ratio that is out there today.
Right.
So let's kind of walk through the benefit of that. At 68 miles an hour, that engine's going to run at 979 RPMs, below 1,000 RPMs, and it's going to have the gradability of 0.8%. So over 1,000 feet, it's going to downshift once it hits 8 feet. Okay.
Right.
And it's going to be running at that RPM in top gear 52% of the time, below 1,000 RPMs.
Okay, and so because I see you have 52% of the U.S. terrain there. How are you getting that number? Is that map data? What is that?
Well, every Volvo truck has a grade sensor in it.
Right. Okay.
And that grade sensor reports information back to our Telemax gateway, which sends this information to Volvo headquarters. And that's over 300,000 trucks.
Okay.
That are reporting back. So it's actual data that these trucks are going over.
Oh, I see. So it's not a map topography guesstimate. Those are actual miles running by actual trucks then.
Yep, it's real data.
Interesting. Okay, very cool.
Okay, so now we're going to go ahead and drop into direct drive.
Okay.
So we need to go up a little bit higher terrain.
Sure.
So you're going to see just a slight fluctuation from RPM. We'll go from roughly 1,000 RPMs to 1,247. So you'll see the RPM gauge just slightly bump down when it starts to increase in grade. And that's at 68 miles an hour, 1,247 RPMs for 1.4% of the grade. Mm-hmm. Again, that's 14% of the U.S. terrain out there.
Right. Well, and looking back, it's still staying in the sweet spot. You're at 66% overall U.S. terrain, still staying within that sweet spot.
Yep, most definitely.
Okay, perfect.
And then when we go into underdrive in the next gear, that's going to run that down at 1,550 RPMs, 1.5% grade. Same grade that the 308 had,
right?
Except we're running 3 gears through that situation.
Okay.
And that's 9% of the U.S. terrain. So 75% of the U.S. terrain is 1.6% grade. So instead of having that engine always run at 1,400 RPMs, we're able to change the efficiency by reducing the overall RPM that engine's going to run at. So we drop RPMs from, say, a 308 to a 215, 210 RPMs different. And we still have the same performance and better efficiency.
Right.
From that type of setup, you'd probably see about a 10% difference in fuel economy. And have the same pulling performance.
Right, and compared to that, that's compared to your best spec without the system and the technology, right? Because you always compare to your best spec, which is a little different for a fleet. Because I'm replacing a 5-year-old truck, right?
Right.
I'm replacing a 5-year-old truck that is giving me even more efficiency. Well, and going back to it, there, I mean, you got 1,550 RPMs. We were talking about 14 as the kind of baseline for what I feel comfortable with, right? And when I know I'll have the power. Well, I have the power when I need it. It's just that I don't always need it. It's not, and it kind of goes back to this thing of if you really want to run efficiently, you got to be okay and comfortable running at what you can run at.
Sure.
And staying within that sweet spot. You don't need, 9%. I'll need that maybe 9% of the time, right? Depending on my route. So really interesting there. From a driver operation point of view, is there anything like, how does it feel? What do I need to know? Or just, kind of give myself over to the system and let it do its job. You know what I mean?
That's pretty much it. Set it in cruise and just let it go. Okay. It'll upshift, it'll downshift just like it's supposed to. It's not going to overspeed. The exhaust brake's going to kick in if you're going over a hill, and just let it shift and let it do its thing. That might be a different feeling for somebody who's been running a manual transmission, but after using this, it's a lot more comfortable experience. Okay,
and you mentioned cruise, so I have to be in cruise,
yes.
Right? And so it's engaged when I'm in cruise, so I'm going down the highway, it's in cruise. You get that feeling. You're coming up on a hill. It's a pretty good grade. You want to get you want to goose it a little bit.
Right.
But just let it go. Watch it do its magic then.
Yeah. And then the other side of that is, you're driving at night. Do you know where that hill's at?
Oh, right.
You can't see it, right?
Right.
I can see that. It knows there's a hill, so it's going to downshift before a driver would even know they were on grade.
Right. And just letting the system do what it needs to do. And I mean, it frees up. Safety is a big topic right now, right? And it's always been a topic, but with new technology allowing the driver to just focus on what's in front of them on the road, being engaged there, not worrying so much about which gear do I have to be and where are my shift points. I mean, just being focused on the road, especially you mentioned at night and all those other situations. We have snow flying here today, right? You definitely want to be focused on the road then.
Yeah, after a shift in driving a truck, you're mentally and physically drained. So anytime we can reduce that stress on a driver, it becomes a much more safe environment, as you alluded to.
Right. Dwayne, I appreciate you taking the time to stop by and give me the rundown on this. Really, really cool when you can see it in action and understand it. And thanks again. I appreciate it.
Jason, thanks again for the invitation. Appreciate it.
Thanks, everyone.